Okay guys, so today we will be learning about relation between torque tau and moment of inertia I. We'll see that how they relate to each other and we will derive the relation. So first of all, we know that torque on a rigid body moving under the action of force F. There's a force F acting on the rigid body and where the axis of rotation's distance from the action of force is r vector. So the torque for that will be cross product of r and the force, linear force itself. This is how we derive the torque for that, and it is the cross product, so we know what we have to do. This implies torque will be equal to rf, that is their magnitudes, and with the sine theta. This is the result of the r cross product. And I will say, what happens if the angle between r and f is 90 degree? That means sine theta will be sine 90 degrees, so which will be 1. So we can simply take the product of magnitudes of r and the f force. So tau will then in that case will become rf in case when r and f are perpendicular to each other. Now we also know that in a linear equation, when we talk about linear motion, so force is the product of mass and acceleration, so ma. This implies tau will become r ma. We have put the value of f here. Now, but in rotational motion, we know that the a is also equal to r alpha, where alpha is the rotational acceleration and a is the linear acceleration. So angular acceleration, so alpha is the angular acceleration. Now we have the value of a, we will put it in tau again. So tau will now become, let me take it as a vector, not a vector, but we're taking the magnitude now. So tau will be equal to m r square alpha. Now again, what's the value of mr square? What is mr square equal to in rotational motion? Yes, the moment of inertia's value is actually mr square for a rigid body. So we will write I, in place of mr square we will write I. So tau will be now equal to I alpha. So this is the relation between torque and the moment of inertia. Here the angular acceleration plays important role. If you product it with the moment of inertia, so it will give you the value of torque. So we know that acceleration and we know that torque is the rotational analogous of the force. In the same way, mass is the, or we can say moment of inertia I is the rotational analogous of the mass. So these two things are actually one of the same things. This is the analogous in the rotational field. Now F is equal to ma. In rotational motion you will write it as torque tau is equal to I alpha.